What we're going to do today is look at first order non-homogeneous differential equations involving e to the ax or e to the by and how we should deal with them. And there is basically a very good rule of thumb as to what you should do. So what we're going to do is we're going to have a look at 3 JEE Main questions, 2 of which use the rule of thumb, and the third one, even though the rule of thumb doesn't work, it does lead us to the correct way of solving. So basically the idea behind all of this is that what we're going to do as a rule of thumb is that we would let z equal e to the ax. And why would we do that? Well, because if we differentiate with respect to x, then we would get dz dx equals a e to the ax, or dz equals a e to the ax dx. And then what we would do is we would replace this in the equation by dz, and we would end up with an equation in dz where hopefully either a, it would be of the form dz over f of z equals whatever dy over g of y, which is separation of variables, or it would end up in the form dz over dy add f of y z equals g of y, which is the first order non-homogeneous differential equation, where we know how to solve that one. We've done a video on that one previously. Okay, so let's have a look at the 3 questions then. So here is the first one here. It's from the JEE Main August 2021 Shift 2. If you want to try it now, please I'll pause the video now. Okay, great. So basically we have e to the y in here. And what do we want to do? Well, what we want to do is we want to use our rule of thumb, whereby we're going to get e to the y dy eliminated in terms of dx. Now, in this particular case, though, e to the y is multiplied by dx, not by dy, but that's not a problem because all we need to do is multiply the entire equation by e to the minus y, and that will give us 2x squared e to the minus y dy, and now we have the bit that we want, add brackets 1 minus 2x e to the minus y dx equals 0. Okay, so now we have e to the minus y dy. So now what we can do is we can let z equal e to the minus y, and therefore dz equals minus e to the minus y dy, and we can replace that bit, which is that bit, by dz, which gives us minus 2x squared dz, because of that minus sign there. You just have to be careful of that. Add brackets 1 minus 2x z, because e to the minus y, we're using the substitution, z is e to the minus y, dx equals 0. Now we can see that this, by the rule of thumb that we discussed for non-homogeneous first order differential equations in the previous Cresty Academy video, because here we only have dz and z, secondly everything else is x or f of x, and thirdly the z multiplies by x, we know that we can put this in a form where we can solve it, and indeed we can. Basically all we got to do now is just move this around a little bit, and we will get dz dx add z over x equals 1 over 2x squared. All I've done there is basically just divided everything by x squared there, and I've moved the dx down. Okay, so we now know that we have this equation here which we can solve. Okay, so let's have a look at the integrating factor here. Well, the integrating factor will be 1 over x. So e to the integral of 1 over x dx is e to the log x, which, as we've seen numerous times now, e to the power of log anything is just the anything. So basically that equals x. And now when we multiply everything by that, we get x dz dx add z equals 1 over 2x. Okay, now when we integrate this with respect to x, we know that this bit here is equal to xz, and here is basically half log x add a constant of integration. Okay, so what we need to do now is, actually we've got the initial conditions here, y of e equals 1. So when x equals e, y equals 1, and basically as we've got this in the form z, and z was, what was z again? E to the minus y, so we can now rewrite this as x e to the minus y equals a half log x add c, and we can put in our initial conditions, which gives us e times e to the minus 1 equals a half log of e add c, and e to the minus 1 is clearly 1, and log of e is 1, so that gives us a constant of integration is equal to a half, and so therefore we now have x e to the minus y equals a half log x add a half, and the question then asks us what is y of 1. Okay, so when x equals 1, what is y, basically it's saying. So when x equals 1, y equals what? So okay, let's put x equals 1, that gives us 1, e to the minus y equals a half log 1 add a half, well log of 1 is 0, so that gives us that e to the minus y equals a half, or taking logs minus y is log of a half, i.e. y equals, just flipping the minus over there, log 2. And that is the answer to that question. Okay, so that's question 1, where the substitution worked absolutely perfectly. Z equals e to the minus y. We saw that it nicely got rid of everything. Let's have a look at another question now, which is relatively similar. If you want to, please pause the video and do it if you so desire. Okay, now this is actually only part of a JEE Main question. The other half of it is not related to this video, so I didn't bother to do it. So anyway, this is what we have. And again, what we want to do is we want to look at, we have an e to the 2x and we have an e to the x. Well, let's try z equals e to the x. Oh, and the other thing is, if we were to multiply this, we would get e to the x dx. So this looks a very good contender for this substitution. So z equals e to the x, i.e. dz equals e to the x dx, and then we can replace e to the x dx by dz, and of course z squared therefore equals e to the 2x, and so now rewriting that, we have 1 plus z squared, sorry, my bad, my apologies, let's just get rid of that. Sorry about that. So we have, let's go back to where we were. Yep, so we have, yes, right. So basically, let's multiply, because I took too many steps there. 1 plus e to the x dy add 2, 1 add y squared e to the x dx equals 0. Sorry, I forgot to multiply by dx. And now we have the e to the x dx there. So we can now replace, use our substitution. So 1 add z squared dy add 2, 1 plus y squared times e to the x dx, which is dz equals 0. And hey presto, now we have a very simple equation, which is just separation of variables. And so now all we need to do is dy over 2 1 plus y squared, this is just the standard separation of variables, equals minus dz over 1 plus z squared. And then when we integrate both sides, we get the integral of 1 over 1 plus y squared is tan to the minus 1, so that gives us half tan to the minus 1 of y equals minus tan to the minus 1 of z add c, and we were told that y of 0 is 0, so basically let's put back the e to the x, so we have a half tan to the minus 1 of y equals minus tan to the minus 1 of e to the x add c, and when y is 0, x is 0, that's the initial condition, so a half tan to the minus 1 of 0 equals minus tan to the minus 1 of e to the 0 add c. Well, tan to the minus 1 of 0 is 0, tan to the e to the 0 is 1, and tan to the minus 1 of 1 is pi over 4, so it's minus pi over 4 add c, so c is pi over 4, and therefore we have the equation, which was only part of the question, we have the equation tan to the minus 1 of y add 2 tan to the minus 1 of e to the x minus pi over 4 equals 0, and that basically is the general equation that we need to solve the rest of the question. But again, for this video, what we're looking at is the substitution z equals e to the x, and therefore z is e to the x, dz is e to the x dx. Finally, the third question, again from JEE Main. Now this one, the substitution doesn't work. But anyway, if you want to have a quick go, please pause the video now. Okay, so this one we would expect when we multiply by dy, we think, oh goody, e to the y dy, why wouldn't the substitution work? Well, the problem is that when we multiply by dy, this would also be multiplied by dy, and that dy there would not disappear in the substitution. So we can't use z equals e to the y and dz equals e to the y dy because it doesn't solve that problem there. So what we need to do is say, okay, right, well, we can't use a substitution involving e to the y, so what can we do? Well, to be honest, there's only one plan B that you can do. You've got to look at this and this. And if we differentiate x log to the base e of x, what we get is, by the product rule, we get log x add x times 1 over x, which is log x add 1. So we can see that the differential of that bit there is that bit there. So therefore, even though the e to the y equals z substitution doesn't work, it leads us to thinking, well, we have to make the other substitution. So let us make z equal x log x, and therefore dz equals, as we just worked out, 1 add log x dx. And then we can do our substitution, and let's substitute this into here, and we therefore get, looking at this bit here, 1 plus log x dx is the same as that. So we basically get dz over dy, that's just substituting that bit for dz, minus x log x, which is z, equals e to the y. And all of a sudden, we have a very simple non-homogeneous equation of first order, where the integrating factor is simply minus 1. So the integrating factor is e to the integral of minus 1 dy, because this is an equation in z and y, which equals e to the minus y, which equals e to the minus, well, that's it, e to the minus y. Okay, so therefore we multiply e to the minus y dz dy minus e to the minus y z equals 1. And then when we integrate both sides with respect to y, integrate with respect to y, well, this side here comes to be e to the minus y z, and this side here becomes y plus c. So we have that e to the minus y, just putting the substitution back in now, x log x equals y plus c. What were the initial conditions? It passed through 1, 0. Okay, so when x is 1, y is 0, so sticking that in there, we get e to the minus 0, 1 log of 1 equals 0 plus c. E to the 0 is 1, log of 1 is 0, 0, so that means that c is 0. And therefore our equation is e to the minus y, x log x equals y. And then the question asks us, it passes through a2, what is a to the power of a? Okay, so when x equals a, y equals 2, so let's stick those two in here. We get e to the minus 2, a log a equals 2, i.e. a log a equals 2e squared, 2e squared. So therefore log a to the a equals 2e squared, and therefore a to the a equals e to the power of 2e squared. And that's the answer to that one. So what we've done is we've done 3 different questions, all involving powers of e to the x or e to the y or e to the whatever, and all 3 of them using the substitution, or at least thinking about using the substitution, z equals e to the x has helped us solve them. Okay, well, I hope you found this interesting. If you did, please like the video and subscribe to the Gresty Academy YouTube channel. Thank you very much.